everyone. Do you hear me? Okay, it's better. So I want to greet all of you and thank you for coming at this late lecture. I know that it has been a busy day, especially this lecture doesn't contain any AI as the previous one. So before I start, I was so nervous to speak today, but then I saw the opening talk of Isabel, CTO of Infobip, and he forgot what he has to say. So I'm a little better now, so I'm a little relieved. But I have notes and presentation slides, so he didn't have that, so let's give him a plus for that. So let's start. As you have seen, my name is Alen Adanic, and I'm in position of software development. I'm functioning as a head of software product development at Abisalto, and I will be talking about how did we build SSDLC in our company and our building. It's ongoing. Okay, agenda for today is about us, Abisalto, our goals and motivations, tools, example of one tool, target state, lessons learned, and way forward. Little bit about Abisalto. It's a new company and it's an old company. New company because it's established 1st of July this year, and old because it was a strategic merger from the King ICT, Omega Software, and Activis IT. Why did we do that? We wanted to establish our foothold in Croatia as one of the leading IT companies and to expand and to have a greater foothold for expanding in the international markets. So that's the story behind Abisalto. We bring decades of experience, deep technical knowledge, commitment to innovation and excellence, and we are about 350 people now. Till the end of the year, we expect about 400 people in our company. What was our motivation for building a new SSDLC in our company? It was multiple. We have various parts of organization, various departments, and various projects. Some projects are 30-year-old old, some projects are 20, some 10, some are new. Some will start today or tomorrow. We have different architectures from monoliths, simple web applications, to service-oriented architecture applications and systems, to microservices. We have a lot of languages, C#, Java, JavaScript, SQL. We develop mobile applications on Android and iOS. We have various platforms and tooling like SonarQube, secret scanning, Kubernetes, Jenkins, Argo CD, Nexus. We have many things, so the consolidation was a requirement for us. So, what was our focus? Our focus was to maintain and improve our productivity while improving and standardizing our security. So we are targeting this sweet spot. We want to develop secure software at the same or the better speed, but in a standardized way, because it's always tug and pull from the security perspective and from the productivity perspective. You have to be secure, but if you're too secure, and you have a huge gap to the market, time to market, and if you're late, you lose business. So, other desired outcomes are standard and faster development flow, secure development, and not slower. Consolidation of tools, exceptions are allowed, but will have to be discussed with our senior roles, architect roles, DevSecOps roles, etc. Easier compliance. We have multiple clients who tend to be like banks or police that have to be secure. Of course, lower costs, etc. But that's not all. There's the right side. Lower learning curve. So because we have a choice for every team, for every person in our team. If he wants to leave for another team, the learning curve is not so steep. If the team gets another project from another team, then again, the learning curve is not so steep. We have a faster time to market, easier upgrading, patching, easier to replace our components in CI/CD pipelines. How did we organize? We gathered our best and brightest from various parts of our organizations, and we brainstormed. We shared knowledge, we talked the way of we are doing things. One part of the company was doing in one way, the other one in another way. So it was an intensive discussion between us all. And how did we start? We start with a gap analysis. We gathered all the technologies, way of working. We got a list of competences, tooling, licensing model, pricing. Pricing was quite a challenge because do you know when you go on the site and you have a base price, intermediate price, and call us price. So it was quite the process. And we got a pretty huge Excel table with all those information. What we did do with that? We crunched, brainstormed, evaluated, the price was issued, the competencies was also some of our pillars that we referred to, and so on and so on. We implemented various proof of concepts. As I've said, contacted a lot of potential vendors. And the result of our hard and dedicated work was decision about our platform. Our requirements for development platform were that it's secure out of the box, that it's a stable and tested project, that we can get full vendor support if we need it, that's easy to get out of the vendor lock-in, and it's easy to patch, install, and upgrade. Why? Because I don't know if any have any experience in upgrading vanilla Kubernetes components and hell that comes with that. So because of that. It is compliant and with no standards and regulations. So with further ado, our platform is OpenShift, Kubernetes-based platform. OpenShift has all the needs that we care about. It's a Kubernetes platform. We have hands-on experience with Kubernetes. We have hands-on experience with pipelines connected to Kubernetes, and OpenShift is a Kubernetes Red Hat flavored Kubernetes. It has underneath it had SE Linux. It has a lot of compliances out of the box with like PSI DSS, GDPR, NIS2. It has network security and encryption and GDPR, incident response and recovery, etc., etc. But the picture is worth 1,000 words. So here is a picture. On this picture, you can see that it can run everywhere, anywhere, on cloud, on public cloud, on private cloud, on hybrid multi-cloud. We have a need to standardize our development in our company, but we have to be ready to deploy on vanilla VMware virtual machines to other Kubernetes and customers, to the cloud Kubernetes, to other OpenShifts or OKD platforms. With this platform, we are ready to go to deploy from our point of view to every other environment. It has a lot of tools that we can use for image scanning, for registries. It supports a lot of CI/CD tools, mainstream DevOps notification, a lot of CM tools also, and it has everything secure supply chain, infrastructure, and secure workloads. So that's about it's all about our platform. The next one is static application security testing. We wanted to shift left security in our CI/CD. So when the program types code and before commit, that the SAST tool is preventing him. So that the code or the API token or the secret or the password doesn't get up to some remote repository. Also, we wanted to have a vulnerability mapping to all the standards like OWASP Top 10, application security verification standards, CVE Top 25, and others, and easy to integrate in CI/CD processes. We chose SonarQube for that process. With that, we have secret scans, quality gates, support for multiple languages. As I said, we have a lot of programming languages in our company. We have improved our pull request analysis and vulnerability mappings, as I said before. After a static application security testing tool, we chose a new container scan tool. We wanted it to be open source. And why do we want it? Because we wanted to get a great security posture and with early vulnerability detection. And of course, easy to integrate in our current CI/CD. We chose Claire because it is embedded in Red Hat OpenShift Quay image repository, and it's easier to integrate in our CI/CD. In the future, if we want to change it, we can easily change it. That's an example from report from Quay, or from Claire, from Red Hat Quay repository. After Claire scanning, on the upper side of the screen, you can see all the vulnerability for Postgre library. In the middle, you have a CVE vulnerability that it's critical. And below, on the bottom of the picture, you can see attack vectors. And you can see all is red, all is high. I deliberately choose some library with many vulnerabilities so you can get the point. The next component is dynamic application security testing. It's the same as in the previous tools. We have to have a CI integration, easy CI integration. It's open source, reporting and remediation guidance, and active and passive scanning. So it's great for creating a baseline in active and passive scanning so that we can see if any of APIs are open, not deliberately open, and if there are any unused libraries. We can easily create custom scripts for advanced scenarios. And if we have a need for more advanced pen testing, we have our internal security department that can create those security pen tests. We choose ZAP, Z-Attack Proxy. I don't know if any of you heard about it. It is another open source tool. So it's great for creating baseline, the basic hygiene. And the last tool that I will be presenting today is software composition analysis tool. Why? Because of all the regulatory standards and the NIS2 that is implemented that focuses on supply chain security and generation of, among others, software bill of materials. What we get out of it, we get easier compliance. As I said, various projects, multiple projects, a lot of libraries, a lot of legacy. With that, we can get an easier compliance, easier license compliance, reduced risks in third-party dependency, and as the previous tools, easy to use in CI/CD. And we choose dependency track for this part of our CI/CD. Dependency track has a Cyclone-DX format that's for vulnerability standardization. It is connected to a lot of vulnerability integrations and databases like NVD, SNCC, Sonatype, OSS Index, etc. It is integrated with all the mainstream platforms and has a support with webhooks if needed. It's integrated with a lot of vulnerability aggregation platforms like Defect Dojo or ticketing systems like Jira software. I have created a test case so you can see and get a look and feel what dependency tracks looks like and how you can set up a policy management. It's very easy and it's straight format. The dashboard of the dependency track looks like that. On the left side, you can create policies for licensing violations and for vulnerability violations. If you want to create a rule, you have to click on the left side on policy management on the bottom red rectangle. After you clicked on that rectangle, you have to get a name for the policy, operator for the policy, and violation state, there are multiple states like inform, warn, or fail. I choose inform for this example. And on the end, you have to create a criterion for alerting. So my criteria was that it has to inform me if somebody put a library that it's not MIT compliant in our code base. So if developer puts some non-MIT library in our code, I will know and I will go to him and say what we're doing. that's not the deal. So it's pretty straightforward. It's pretty easy. And how does it work? As I said, easy. On the left is example for .NET Docker file for generating as a software bill of materials. You have to add Cyclone DX tool in your Docker container. You can see it in this red rectangle, and to define the output path where you save the build output. The next thing is you have to upload this software bill of materials to dependency track. We are using Jenkins as our integration and build agent, and you have to put with already available library to upload this file to dependency track, and that's all. Then you observe the results, and you can get notifications from alerting, and I will show you in a few bits how to do that. So you can get a CVE with detailed vulnerability, with online references to online databases, and some scores. If you click one of those databases, you will get a page like this in the middle with score and more detailed description if you want. And if you want, you can manage your alerting. So I set up it, alert me if it is a new vulnerability, if it's a new vulnerability dependency, if a policy was violated. And that's all. You can get it done with AI and LLMs, ChatGPT, in half an hour. The tricky part is to integrate it in your company pipeline and to force everyone to use it. Summary of our platforms and tools that we reviewed today. As a platform, we used OpenShift, which helped us to streamline our development, dependency track for vulnerability management, for easier tracking of licensing and vulnerability violations, especially with NIS2 and directive and other security standards. ZAP, Z-Detect proxy for dynamic application security testing, SonarQube for static, Claire for container scanning, and we are always open to new tools. We are always open to proof of concepts. If one tool doesn't meet our criteria or our requirements, we are happy to replace it, but with some rules. We introduced new roles, DevSecOps or site reliability engineers. When we got all of that security issues, we had to centralize that, and someone needs to work on those issues. So this role works with development teams and block promotions to productions if there are non-compliant security issues. And they are all recipients of those alerts, and they were not so happy when we told them that. So there's a lot of dissatisfactions from them. But that's all water under the bridge. Target state visualized. So at the bottom, we have OpenShift as our platform, Jenkins our CI/CD tool, build agent, Argo CD as our deployment tool, and dependency track as our vulnerability management tool. At the upper part of the picture is our process simplified with SonarQube for static analysis. Nexus, we also got Nexus for binaries, dependency tracks also for SBON generations, and Claire and ZEP for vulnerability scanning. Lessons learned. You can build this and enforce this. It's enforce this if you don't have a strong DevOps team and technical leads. You have to have a lot of patience and continuously raise awareness and training. No tool will prevent some human or developer to click on some phishing email. So we have to raise security awareness and training for, repeatedly. Start with a few smaller and easier projects to transfer. We got the routine, we worked some beginner's mistakes, and we are currently working on migrating bigger projects, bigger legacy projects, and fixing things as we go. What we achieved and what we hope to achieve in future is a strong baseline, is delivery speed and security that we can easily build upon in the future. So, hope to see you next year, and I have 8 minutes left. Hope to see you next year, and currently we are looking in Project OpenCRE to map all the requirements from the security standards. OpenCRE is a nice tool that can help map vulnerability across standards. So if you are standardizing 27.1, you can map it to OWASP or NIST or NIST2 easily. So you can speed up your certification of security process in your company. And we are investigating the best way to integrate AI and AI agents in our CI/CD. We are not a fan of uploading our data to the cloud. And I have to mention that because here is my head of AI in the first rows. And he said that I must mention AI in some sort. Thank you. That's all for today from me. Thank you for listening. If you have any questions, you can add me to LinkedIn or you can catch me after this presentation. I will be happy to share our experiences. Thanks.